Hi everybody, Dr. Pingel here. I'm going to be recording the lab report for November 30th. It's actually the 29th today. Lots of stuff to talk about. All right, one of the first things is that I finally got a chance to fly the Mavic, and it is super nice. That photo that you saw at the beginning was shot by one of the CNRE media people on Friday of just before break. So nice to get some promotional photographs that we can use for the lab. Um, that day went pretty well. So I had requested to fly an actual scan on the Virginia Tech campus. There's a bit of a mix-up between with the email. So they had actually approved the flight, but I didn't know about it because I didn't receive an email. So we ended up going out to the Virginia Tech drone park, which is kind of a netted area, and ended up talking with Greg Calvert, the guy that's in charge of the drones at Virginia Tech. And so he told us that we were good to fly, so we went back and flew a little bit by Major Williams Hall, where the geography department is. I also flew a flight here at my home, so we've got kind of a rural area here. It was really easy to fly. Um, uh, I really liked the flying the Mavic. Super duper easy to fly. I've never flown anything easier than that. Really steady in flight, so that was really cool. Um, Played around with the Pix4D flight planning app. So this is nice for a couple of reasons. One is it automatically lets you fly a double grid, which we previously had to do manually on our other drones. So that's a nice feature. It also only takes pictures when you want the pictures to be taken. So instead of what we usually do, which is fly a GoPro and have it take a picture every second, and then just select every other image or every third image based on the altitude, we can really kind of custom tailor this, which makes for less data acquisition and faster processing. Uh, Flying it was the connection quality between the transmitter and the drone was awesome. Didn't have any single problem with losing signal. Battery life is rated at half an hour. I didn't really push it too hard, but it seemed just fine. The video connection coming in from the drone, you get first-person video, which is great. Really easy to frame shots and kind of make corrections in flight. So some really good advantages. One of the photos had an error, and because there's not much redundancy, because you're only taking the photos that you need, that could potentially create a problem with a resulting point cloud that's very valuable. And so that was a little bit off-putting. The geotagging went haywire, which was even more off-putting, especially given the problems that Earl has had in the past. And I'll show you an image of that. And then the images that I got back were okay, but not great. I really need to kind of tinker around, and I think setting them to manual settings and kind of controlling the exposure manually is going to result in more even data collection, and Earl can probably attest to that as well. This is an example of the flight pattern that I did and the GPS problem that I ran into. So you can see that for some odd reason, the GPS tags for about the first quarter of the flight got moved about 2 kilometers to the east. I have no idea why this happened, but it meant that I had to throw away all the geotagging information from the flight and just run it without. When you do that, the information is still metrically correct, but it isn't geolocated properly. Not a huge deal for the sample data set, but hopefully this isn't a recurring problem. I did make a lot of progress on the RU, so a couple of things to report here. One was that I grabbed the 31 active GPS stations for Mexico. I ended up doing this kind of manually, copying and pasting from the national map equivalent for Mexico, which is Gaia. Kind of a pain, but it was something to do over Thanksgiving. Um, so I didn't do an analysis on this. The analysis that you see down below here is with the CONUS station, and the first 2 lines, the Aster GDEM and the SRTM 30 meter, weren't my analysis. That comes from the literature. I did run the analysis on the 90 meter stuff. Actually made some headway here using the 90 meter data set that I had, and I found out that if you load it into a float type, raster, mosaic, the estimates that you make from the interpolation that come out of that are also going to be floats, which means that they're just slightly more accurate than the integer-based measurements. All of these global satellite products are really just rounded to the nearest meter, and so by using a float, you can actually improve your bilinear interpolation by, it's not much, but say 5 or 10%. Um, uh, I would like to, in a previous slide, I talked about getting the global 30-meter SRTM dataset that is in. I also started downloading the GDEM2 dataset, so I got this from NASA's Earth Data Portal. You basically request all of the different tiles, which they call granules. They email you a link to a zip file that contains 2,000 of them. And so there were like 12 total links that I had to get. So I just plugged that into wget, and that's downloading right now. It's about a third of the way done, about 250 gigabytes in total. While I was looking for that, I also ran across this, which is GDEM3. I haven't heard a peep about this. Kind of ran across this by accident. If you look at the date on this, it's November 27th, and I ran across it on November 28th. So I'm going to look into this a little bit and see if it is for real. If it is, then I'm going to download it. So the active stations, there are only 31 active GPS stations for Mexico, at least posted on Gaia. I'm more interested in doing kind of a bigger analysis. I've been having some trouble getting hold of the entire passive network. I've presented a little bit on what I thought were some good solutions, and they ended up not working out. And so long story short, I emailed or did a chat session with somebody from Enegi while I was on Gaia. They were really nice and said that they'd forward my request on to somebody else. Those people emailed me back with a spreadsheet that contains the latitude, longitude, orthometric height, and ellipsoidal height for all of the markers in all of Mexico. So this is great. I haven't done much with it other than kind of browse it, but hopefully next week I will have some results from that. And the lesson here is don't just take what you find on the internet. Don't be afraid to send a help email to somebody. I was, in writing the report, I wanted to write down what the resolution was, the ground resolution of the images that we were taking. So that kind of led me into looking up some of the ground sampling distance calculators. So I used one of the ones that's available on Pix4D that you can see linked here. Basically plugged in the specs that I got from GoPro and other places, and came up with a ground sampling distance of 1.09 centimeters per pixel. That seemed rather fishy to me, so I plugged it into this, which was another online calculator. This one from Propeller. It gave me the exact same figure of 1.09 centimeters. So I did a little simple trig to try to figure it out. My trig-based estimate puts it at something like 11 centimeters, covering a footprint of about 445 meters. This is supposing that we're flying at 122 meters, which is 400 feet. And the 122.6 degree mark comes from here. So according to the GoPro statistics, that's the horizontal field of view. So which of these is right? Well, I loaded up some images that I knew I'd flown at 400 feet. This is at the NIU campus. And so you can see that this goes from about the track, which is over here, to the second row over, which should probably be about here. So that total distance that you see marked here was 455, which jives pretty well with the back of the envelope trig estimate of 445, especially if this dot should actually be moved over here. Anyway, ground sampling distance is probably 11 centimeters then, according to this math. I don't see anything wrong with my math here, which means that both the spreadsheet and the website are off by a factor of 10, and I don't have a really good explanation as to why that would be. The last thing that I worked on was Waldo-Tobler's pycnophylactic interpolation. So this was a raster resampler or vector to raster conversion method, and the idea is it's sort of an iterative sweep through. You calculate a local neighborhood average, use that to sort of reallocate the bars. In this case, Waldo Tobler makes the analogy of sort of molding clay here and smoothing it out, and then sort of snapping it back to its group average to make sure that it's preserves mass. So the idea here is that the average height of the blue in the top should be the same thing as the average height of the blue in the bottom, even though the overall is smoother. So it's mass preserving. So I actually had a pretty easy time implementing this in Python. I used some OpenCV to do it. Basically, I looked at the photograph of Lincoln that he had, trimmed out the relevant piece, used an interpolator in OpenCV called interarea, which is also a mass preserving resampler, and so kind of downsampled the image to, I think, 20 by 16 pixels, maybe a little more than that. And then tried to scale it back up again to see how much of the original image I could recover using both the pycnophylactic interpolation routine that I wrote and just a standard cubic interpolator. There's not a lot of difference between these two, which kind of speaks to the fact that maybe cubic is just fine, and maybe this concern with an areal-based interpolator and a point-based interpolator is overblown. But I need to do a formal analysis on that to sort of see what can be done here. And the pycnophylactic interpolator gave me some ideas about maybe ways to use sort of a combination approach to rescale the cubic interpolator. This is just a little snapshot of the code. I'll paste this in with it so you can look at it later, but not really a lot going on here. Most of the work for the pycnophylactic interpolation is happening between lines 33 and 40, so super simple code to make this happen. A couple of kind of side notes. One is I was driving around Blacksburg today and saw this. So it was a truck marked as an autonomous vehicle that had a spinning LiDAR unit on its head. Looked like the Velodyne 64 to me. So this is a company called Torque. They are making autonomous vehicles, and they're based in Blacksburg. So that was cool. Maybe some people to talk to at some point. And then the other thing is I ran into this, which is a SLAM algorithm called SeqSLAM++. I didn't look at this at all, so this is mostly just a note to myself to follow up on that. So the goals, this was actually a pretty successful week for me, I guess maybe because it was really 2 weeks. I made a lot of really good progress in the RU report. I flew the Mavic, and I worked on the spatial interpolator. I did not get a scan of the Virginia Tech campus, so I got to do that. Next week, probably pretty much the same as this week. I'm going to keep focusing on that RU report, work on that spatial interpolator as kind of a secondary thing, get the GDEM3 dataset if it exists, and maybe fly on the Blacksburg campus if time permits. So that's it for me. Look forward to hearing from you guys. We'll talk to you later.